All right, let's dive right in. Today, we're going to build one of the absolute cornerstones of programming, and we're going to do it from the ground up in C. We're talking about creating your very first linked list node, the single building block for some incredibly powerful tools.
But first, you might be asking, why should I care about this? Well, have you ever wondered how your music app just lets you keep adding songs to a playlist, or how your browser history keeps track of every site you visit? The thing is, these apps have no idea how much space you're going to need ahead of time, and the answer to how they pull it off lies in a really simple but brilliant idea.
And it all comes down to this one thing, the node. It's this single, super flexible little building block that makes all of these dynamic, constantly changing lists even possible. So today, we're going to build one from scratch.
So what exactly is a node? The best way to think about it is like a single car on a freight train.
Think about it. Every single car on that train has two things that really matter. First, it has a space to hold stuff. That's the cargo, right? For us, that's our data. And second, it has a coupler on the back to hook up to the next car. That coupler, that's our link. And that's it. Seriously, it's just a piece of data and a link. That's a node.
Okay, so the concept is solid. We get it. It's a train car. But we're programmers, right? Before you can build something, you need a blueprint. And in C, we're going to design that blueprint using something called a struct.
That tool is called a struct, which is just short for structure. And its whole job is to let us group different kinds of variables together into one neat little package. For our node, we need to bundle two things, a number for our data and a really clever type of link that's going to point to the next node.
And this right here is what that blueprint looks like in the actual code. We start by saying we're defining a struct, and we're going to call it node. Simple enough. Inside, we declare an integer called data, that's our cargo bay, but then we have this second line, and this is where the magic really happens. Struct node star link. Let's break that one down.
This maps perfectly to our train car analogy. Int data. That's easy, that's the cargo. But struct node pointer link, that is the coupler. See that little asterisk there? That little star means this is a pointer, and that's a huge deal. It means this variable doesn't hold another whole train car inside of it. Nope, it just holds the memory address of where to find the next one. It's like a GPS coordinate for the next car in the line.
And this brings us to a super important term, a self-referential structure. It sounds really fancy, I know, but all it means is that our node struct, our blueprint, contains a pointer to another node strict, another thing made from the exact same blueprint. This is the secret sauce. This is the trick that allows one train car to know where the next one is. Without this, you just have a yard full of disconnected cars.
Great, our blueprint is done. But a blueprint is just paper, right? It's not a building. Now it's time for the construction phase. We have to actually build our node and bring it to life inside the computer's memory. And this brings us to a really crucial point. Just defining the struct doesn't actually create anything. It's just a plan. You have to explicitly ask the computer to set aside some memory for it. So how do we do that? Well, it's a pretty simple three-step dance. First, we need to declare a pointer. This is going to be our handle. It's how we'll hold on to our new node. Second, we use a C function called malloc, which just stands for memory allocation, to ask the system for a chunk of memory that's just the right size. And third, we connect our pointer to that brand new chunk of memory.
And believe it or not, all three of those steps happen in this one single powerful line of code. We have our pointer, called head. We assign it the result of our call to malloc, and we tell malloc exactly how much space we need by using sizeof struct node. And boom, just like that, our node is real. It exists somewhere in memory.
So, we've built the train car. Awesome. It's sitting there in memory. But right now it's empty, and it's not connected to anything. So let's add the finishing touches.
Now to get inside our newly created node, we need a special tool. Because we're holding onto it with a pointer, head, we can't just use a simple dot. We have to use this guy, the arrow operator. It's just a dash followed by a greater than sign. It basically tells C, hey, follow this pointer to where the node is, and then let me access one of its parts.
Let's start by loading up the cargo. The line head.data is pretty straightforward. We're saying go to the node that head points to, find its data field, and put the number 45 inside. And just like that, our train car is no longer empty.
So what about the coupler, the link? Well, right now we only have one car, so it's not connected to anything else. We need to set its link to a special value that basically means this points to absolutely nothing. And in C, that special value is null.
Now, it's really important to understand that null isn't the number 0, and it's not an error. It's a very deliberate signal that says this is the end of the line. Later on, when we're moving through our list of nodes, seeing null is how our program will know it has reached the very last car in the train. It's the caboose.
And just like that, we've actually done it. We have successfully designed, built, and filled up our very first node. Let's do a quick recap of everything we just managed to accomplish.
So we started with a struct to act as our blueprint. We made a pointer to be our handle, to keep track of it. We used malloc to actually ask for memory and build the node. Then we used that cool little arrow operator to load its data and set its link to null, officially making it the end of our very, very short one-car train.
And I want to leave you with this one last critical piece of advice. That pointer we created, head, it is not optional. If you call malloc to create a node, but you don't save its address in a pointer, it's like building a brand new train car in the middle of a massive rail yard and then just losing the map to find it. It's there, but it is lost to you forever.
So we have absolutely mastered building a single car. We can create it, we can fill it with cargo, and we can mark it as the end. So the obvious next question is, how do we add a second car? How do we take that null coupler and link it to something new? In short, how do we build the entire train? Because that right there is the foundation for everything that comes next.